Is there anybody out there? All the endpoints are closed. We haven't any rest since the zombies arose. They're getting all the humans and then putting them down, patching all the clients and deleting the town. Surviving through the night, we need authentication. The secret to our broadcast is content negotiation. They're after all our brains and we're biting our nails, surviving APIs with Rails.
I'm Carlos Souza and you're watching Surviving APIs with Rails. In this level, we're going to be going over REST, routes, constraints, and namespaces. But before we dive into these concepts, let's take a look at a web-based service from the perspective of an end user. We're going to look at how a music streaming service works. Let's take a look at an example application that uses a web API. This is a music streaming service, and it can be accessed from different applications. You can access it through a web browser and, for example, create a playlist, which you can access later from a different application, say a mobile phone. The phone can access that same playlist by reading the web API, which will provide data for all different sorts of applications. Let's explore a little bit how the communication might happen back and forth between the web API and its different clients. In this example, we have a client that first creates a playlist. That communication might be something like a create command to a specific thing, in this case, playlist, passing a couple of arguments, song 1, song 2, and song 3. We get a response back from the server that says, okay, here's a playlist that you've created and it's called playlist 13. Then later, if we want to read the playlist, we can issue commands like read playlist 13. Then the server responds with, okay, songs 1, 2, and 3 belong to that playlist. And the same thing, if you want to read all the playlists that you have, you can ask the server to return that for you. And a response might be, okay, here's all the playlists that you have, playlists 11, 12, and 13. At the same time, if you ask for a playlist that doesn't exist, the server might respond with an error message saying invalid playlist. The server knows how to respond to different kinds of requests, including invalid requests. Notice the pattern here. We're talking about a set of commands that are performed on things which generates responses. This is the foundation of a REST API. As you may know, REST stands for Representational State Transfer, which allows building an infrastructure that can support different types of applications by following a very strict set of operations. Throughout this course, we're going to be talking all about how to build REST APIs in Rails and some common practices to keep in mind. A good starting point for implementing our API is our routes file. In this example, we have a resources definition for zombies. As you may know, the rake routes command gives us a bunch of information related to the resources that we have available for us. So we can see all the different HTTP verbs or methods listed and the URIs that are available for us. We may not need all of these routes, and the resources method gives us some options that we can use to restrict the routes that we have. This will help us improve memory use and can also speed up the routing process. Using except here, we can restrict the destroy action. So when we run rake routes, we can see that the destroy action is unreachable. Using the only option, we can restrict our routes to only allow the index action. Both only and except can also take an array of actions. In this case, we're restricting the zombie's resource to only allow for index and show actions, and the human's resources to not allow destroy, edit, and update. Here's what our routes look like. Here in this routes file, you can see that we're using the same restriction over and over again. The with options method is an elegant way to remove duplication out of our routes file. Here you can see we're calling with option with only index as an argument. The arguments are automatically added to the resources inside of that block. You might have seen before APIs that reside on its own subdomain, and this is smart because it allows us to load balance traffic at the DNS level, which is way faster than doing it at the application level. Here in our routes file, we can see we have the episodes resources, which can be accessed through the top level domain. We also have the zombies and humans resources, which can only be accessed through the API subdomain. We can do that using the constraints option, passing in the subdomain that we want to use. Another way we can write this is using the constraints method that takes the subdomain as an argument in our resources inside of a block. This technique is extremely useful if you're using the same Rails codebase to serve both a website and a web API. Now, before we can run this in development, there's a couple things that we have to do to our network configuration. If you're using OS X or Linux, you want to edit your etc hosts file. Inside of that file, we're going to map our local network interface, which is 127.0.0.1, to URLs that we can use in development. A pattern that I like to use is to append -dev to whatever website I'm working on. In this example, cs-zombies.com is the production URL. So we're going to create cs-zombies-dev.com for the top level domain and api.cs-zombies-dev.com and the API subdomain. The following URLs are now available on our local machine. Keep in mind that the port number is still required. Other alternatives to do this are tools like POW or services like lvh.me, which we're not going to go over in this course, but here's the URL so you can check it out. Going back to our previous routes file, let's see how we can keep our controllers a little bit more organized. In this example, all of our controllers are under the same namespace, which means under the same folder, which might be a little bit confusing once you start adding more classes to your project. To fix this, we can create a separate namespace just for our API controllers. As you can see, our API controllers are now under the API folder. We now have our zombies resources, which are part of the API namespace. This means that when we define our zombies controller class, it needs to go inside of the API module, and that file needs to go under the API directory. Our pages controller, which is not part of our API, still remains at the top level namespace. Enforcing both a subdomain constraint and an API namespace gives us the following URI, which is kind of ugly. There's unnecessary duplication. We're repeating API both at the subdomain and as part of our path. We can fix that by passing a path option to our namespace, specifying root, just slash. This way, we strip out the API part of our URI, but still preserve the namespace, which looks much better. We can use a shorter syntax by passing both the constraints and path as options to the namespace method. You might have noticed that when we define our zombies controller class, we wrote our API module in camel case, which is Rails' default convention for naming classes. But it's kind of weird because we typically write acronyms all in caps. But if we try writing API all in caps, it wouldn't work. To make it work, we need to add an entry to our inflections file for API. Now we can write our API module all in caps, which makes it a little bit easier to read. So that's it for level 1. Now get ready for some challenges.